solve this problem, I made the app EcoTimelapse AI to look at trends in the environment and predict how those will change over time. It then puts the data on a map to view. It tracks desertification, glaciers, forest cover, wildfires, and ocean levels across 3 regions, those being the Amazon rainforest, the Sahara Desert, and Greenland. It covers time periods from 1970 to 2100. And it also provides AI-generated summaries of the damage for that time period, as well as steps to limit the damage. Okay, now a demonstration of the app. This is how it looks. On the left side, you can select the location you want to measure something for. So either Greenland, the Sahara Desert, or the Amazon Basin. You can also choose the feature you want to measure. So for the Amazon, we could do forest canopy and native vegetation. And you can choose the year you want to simulate, as well as the policy you want to choose for how it will change over time. So for the Paris Accord, we can do 2070. If you click on Verify Logic and Execute Simulation, it will zoom in on the Amazon Basin and provide a highlighted area of how much of South America will be covered by forest in that year. So if I then go ahead to 2100 and click it again, it should get smaller, which it does. Then here, it has a bunch of different statistics about how it changes from the current year, 2026. So if I choose the year as 2026 and execute, then all of these will change to 0 because that's the present. Or these will stay as how it is right now. On the right side, under AI Prediction Synthesizer, it gives you a summary of the change that occurs. So for 2100, it says this. Down here, it shows how much change occurs in the size of the forest for each year from 1970 to 2100. Up here, you can see what the weather is of the region you choose right now. And here, it can give you a strategy of how to reduce the damage in the future for the feature you choose. This also, I can show you for other regions as well. So glacier zone and glaciers for 2040 would look like this. But in 1970, it would have looked like that. That is pretty much everything for the app. So the team that worked on it with me was myself, who came up with the basic idea about the specific version that I showed you. Then the 2 others on my team were Ishan and Tanay, who also worked on their own versions of the app using their own unique features. And our mentor, Kushal, who provided us with the code and taught us how to make and edit the app. The impact of this app is that it can help people anticipate the change in the environment over time and document how it's already changed. It can help prevent damage to the environment before it actually happens. It can help guide the decisions of others to make it easier to reduce the impact to the environment. And it can help you compare changes to different features over time. Do you have any questions?
Sorry. Jaideep, would you like to ask any question?
Sure, I have some questions. So tell me more about the data, like where did you acquire the data from? What was the data about that helped you build this app?
I don't know exactly, but I'd assume it would just be different statistics about how much of what region was covered by the feature that we're measuring.
What else would be there in that data other than the regions?
The rate of it being increased or decreased in size, as well as the factors that caused it to happen.
What type of factors?
Global warming, for example, how that has affected the temperature would have probably been used to show how glaciers grew or shrank for the year.
Oh, So what would be that data? Like temperature in each region, like what would that be?
If you go here and select this, it'll show you what stuff matters. So that's probably the same stuff that was measured. Carbon emissions are probably the main thing for specifically glaciers. Deforestation, just people cutting down trees would be a big one. So yeah.
Did you when you trained your model, did you tell which features you want to use for your prediction, or did it choose the features from your data by itself?
When I was given the basic code, these features were already chosen.
Okay. So would you call it, in that case, would you call it supervised learning or unsupervised learning?
Probably supervised because I already knew what the stuff was.
Okay, sure.
All right.
One more question. One more question.
Yeah, sure,
how did you verify how true your predictions are?
I looked at it
The
and
model's predictions.
I just looked at it and see if it looked at it and assumed if it seemed right or not.
Shape wise, yes. I can just put an offset on the shape, on the polygon, and make it look right. And that's not actual measure of correctness. Like how that you can fake it, but how do you build confidence that you're, and obviously you don't have data of 2100, but you are able to predict for 2100. So how do you verify that your projection is correct for the years that you don't have the data for?
There's no way to verify that's actually correct until it actually happens to know if you're correct or not.
There is a way to verify between using the data that you already have, that your model is correct.
You can probably just look at some other person's way of doing this.
No.
And compare them.
No.
In that case, I don't know.
Did you divide your data into like 2 parts when training the model?
I didn't do any of the training really. That was already there.
Okay. Okay. So the answer is, if you had data until, let's say, 2500 or 2020, for example, you could show the model, train the model with the data until 2010, and then make it predict the deforestation for 2015. And if then compare with the actual data of 2015, and if that turns out to be correct, then your model is correct. Right?
So it would just be if I did 1990, and if this is what actually was in 1990, it would be correct.
Yes. But if you basically have to compare it with the data that the model has not seen yet. That's your validation set.
Okay.
Right? The model should not have seen the data that you use for validation. So that's why you separate your training data and validation data separately, so that if the model predicts the validation data correctly, and then you compare it with the actual validation data, that's how you measure the correctness of your model.
Okay.
Yeah, so this has been the best technical round so far. And these were the 2 questions mainly that I was going to ask. And definitely, Om, review the session once, the mentorship sessions and the instructor sessions once. Yeah, I think I don't have any more questions. I was going to ask about the prediction model and how accurate do you think the results are, but definitely Jaideep has already asked you those. So let's move on to the feedback part, where we'll have another panelist and he'll carry on the session. So it was really nice meeting you, Jaideep and Om, and have a really great day ahead. Okay, please stay on the call.